Attention, please. Hi, everyone. So we are going to start the keynote session. So, excuse me, may I have your attention? Okay, so we are going to have the keynote session. So right now, so I would like to introduce Professor Hiroshi Esaki from University of Tokyo. And he is going to provide his talk title is Global GX DX Infrastructure with Native Digital and New Energies by EP100 for Carbon Neutral. So please welcome him with a big applause.
Hello. All right. Thank you for invitation. Basically, this camp focusing on trust and Web3. So that is about energy. That's a little bit tricky, right? Though the reason why I pick up this is the Web3 blockchain consume huge energy, right? Or bit mining, Bitcoin mining, that is huge impact into your energy system. The other thing is those computer systems run by you, not by company, not by government. And also your computer be able to collaborate with power infrastructure, which is a bi-directional, a computer control system using AI, right? So this is a very good example you can tackle on for the future generation, how to protect the Earth against the global warming effect. And also we are strongly talking with the many stakeholders in the world, in Japan, about the bit and bytes, that AI, and what, that energy. Those two are now getting collaborating to each other. In order to operate those two huge global infrastructure, we need a trust among all stakeholders, including you, government, private companies. We must have very trustable cooperation or relationship. The other one is both computers, data centers, and energy infrastructure has huge supply chain, a supply network, which is a subject of blockchain or trust. The trust is the target we are going to establish in those particular huge global multi-stakeholder system. Then the trustworthy, that is technological keyword. How to provide the trust? The trustworthy is the goal of the technology in order to establish the trust. That is always we are now, discussing what the difference between trust and trustworthy. Right? You are younger people, so you working on trustworthy methodology or algorithm or technologies. So when you are senior guy, they are talking about trust. What kind of trust we must establish over the networks? That is the subject of this. So how to cooperate about the AI, bit and bytes, and what? Energy. As an example, as a critical use case of trusted supply chain or supply network with trust and trustworthy. I may think the following keynote speakers may touching on what the difference between trust and trustworthy. What kind of infrastructure we must making about. So this is my understanding about cybersecurity and trust across data spaces. In about a few years, recently, people are now starting discussing about data space, right? Other data mining or data analysis, there are many data spaces. They were independent in the past. So you are now getting all of those data, integrating them. That's the integration of the data spaces. So I put the S as a red color. Though we are sitting on the internet, you are the children of the internet infrastructure, right? So what is the premise of the internet as a by design? This is the internet, freely created, shared, modified data using unified technology, that is TCP/IP, over the physically federated global system. I use the here. That's a single, unique infrastructure, right? Also, that data is transcending national boundaries. We have many nationalities here, though the internet basically doesn't care national boundaries. Data can travel around the world across the national borders. So that is highly related with the trust or trustworthy, because of the government discussion is quite critical. And also new services created from autonomous, decentralized P2P system. That's the first stage of the new services. That's the history, when you carefully look at the history of the internet services, almost all of the services, new services came from P2P. Means distributed autonomous operation was the first. Once that service is going to be, evaluated by users, we have the businessman, right? Kotaro-san is academia, making a new services, right? Benson making money. That is always the experience in the past. Starting from P2P, go to the client server system. Right? Though from the viewpoint of the architecture point of view, always we are thinking about the small start small, scale fast. That is architectural consideration we always think about. We never think about larger scale from the beginning. So when we think about architecture, we always think about scalability in the architecture. Right? That's the reason why the module structure or not. The other ones, we do not optimize the system architecture. Because first is small. The system is going to be large. Environment, the condition going to be changed according to your activities. Therefore, we intentionally do not optimize the system. Reason why the system which can change will survive for the larger scale system. Right? So that is the big challenge to the academia for many times. Professors like very detailed architecture, but that's never be able to scale fast. That is a lesson I've learned. The third one is that we created data spaces, that multiple a lot of spaces that are connected across the borders and are technologically diverse on the globally distributed autonomous space. That is an important thing. Think about the trust or trustworthy of the data for AI system, especially. The other one is operation in a multi-stakeholder environment, including country, which is a critical stakeholder. It's not the critical stakeholder. Country is a critical stakeholder. So who is the important player in this? So that's the reason why today I put the energy system. Energy system was controlled by the government one way. But that's going to be changing a lot, bi-directional thing. So that is changing from telephone network to the internet. Telephone network was unidirectional control system controlled by and run by the government. It changed to the internet. Then the government is a critical stakeholder. That is the understanding of myself for the multi-stakeholder discussion. The last one about the trust. Well, trustworthy methodology is the distributed, coordinated operation across multiple trust anchors, not a single trust anchor. When we talk with the government, they really love single trust anchor point run by them. And they want to make a law that use those trust anchor by every single citizen. So that is not true. Distributed and cooperate to each other by the multiple players, which has to trust anchors. You run trust anchor. You trust anchor. You must cooperate to each other in order to make distributed trust platform, trustworthy platform creation. That is the lesson from the internet history. Okay? What's going to happen after 2025? From this year, systems that were disconnected will be connected and creating a new data space. Today, I put the energy system that never connected to the internet, right? So they are going to connect it. So how we make them happy to the part of the internet is a critical thing, that including the factory as well. Benson is now working with the semiconductor huge industry. Semiconductor factory is now online. Fully robotics, software and hardware robots there. Used to be, it was disconnected. The most of the industry now, including the factory or robots, is going to be connected. That is never senior people experience in the past. You experience. You must work with those new areas which were not connected. They never had such an intention. Though in about 3 or 5 years, when I talk with the bioengineering or neuroscience people, every single factory, every single laboratories are now controlled by software and hardware robots, not by human being. When we have the human being in the lab, data is going to be bad. Product efficiency is going to be decreased by human being. Why? Human being has a lot of bad virus and also 300 watts heating source, which is very bad for laboratories or factories. So they really love to use robot. No virus at all, right? That is, every single country or every single advanced industry is going to use those things. So that is new challenge, real challenge to you. So this is the understanding about the internet. As I mentioned, logically unique TCP/IP that we did, right? Matsumoto-san PAP did it. We have the unique technology, wide variety of the wireless or optical, whatever you have. Then diverse data spaces. We have wide variety of the underneath technology unified by the single digital packet that is the internet. Though most of the younger people see diverse data spaces over the internet. right? Web3 is one of the things. At this moment in time, I think the Web3, creating unique data space over the internet, that's not a single space, but a diverse system going to be established, like Baidu, Alibaba, Facebook, Apple, Google. They have their own data space using their different diverse technologies. You may want to use the same technologies among them, but that's quite hard to do at this moment in time. I'm sorry, that's our failure, probably. We could not make a common technology to connect them using the unified technologies, which means you must have another solution. I think that is a discussion afterward about how making Web3, how making a data space integration and trust, and making a trustworthy technology over that. So this is, sorry, the smaller slide. That is stupid, I'm sorry. Bad Japanese government people make this slide. This is a data integration, data collaboration plan about 5 years ago. We want to use any single data among any single users. That is upper layer thing. Right? Lower layer is many industries having data or systems. The red part run by government. That is their proposal. Means users and the infrastructure must use government infrastructure. I fought with them. I let them change this, because the government is a critical stakeholder. This is what I did. Changing from the data must transfer through the government, going to be changing. The government be able to provide a trust anchor to the industry. And also that is a trust anchor. Of course, the industry be able to provide trust anchors. Trust anchor run by the government is just one of trust anchor. Because some of the data space may have national boundary, may cause of the national law or regulation. So when we talk about your private life or private company activities, you don't want to think about national borders. Right? So that is one of the examples how you think about trust as a multi-stakeholder discussion. Most of you are technological experts, so you may not want to discuss about such a political discussion. So this is a good chance to talk among you, from the technical expert to the political expert or industrial expert, can discuss to each other. That is multi-stakeholder discussion, right? So this is basically I want to share. Then I give you some example about the AI, bits and bytes versus energy. This is the very small figures. So AI with digital twin. Digital twin is a keyword for the Web3, right? The fully copied information of the physical domain. It's called the digital twin. AI with digital twin. The Benson is working on such a case, using every single config file or drive data. He making a digital twin of the computer network. Then the AI grasping, understanding all of the digital twin way of the running system. Then he can ask the AI, what's the problem? Where is the security vulnerability points? That kind of thing, the AI is good. Because when you are running the computer system, you have a lot of management softwares, not only one. You have more than 10 management systems, management protocols, right? What he did, or what the AI people are doing now, is every single data of the management software is going to put into the LLM. Like every single information going to put in the LLM, then the AI is going to be making LLM. Then when you ask them, integrated data from the multiple management software is going to be single aggregated data space. That is now they are talking about, right? And also, since we have those very intelligent controllability of the users, now users be able to be a subject for the controllability that demand response capability. That's not only from the energy point of view, but from the viewpoint of the computer network operation. Once again, the internet was bidirectional, autonomous system. So the end user is a part of the controllability. So how we collaborate to each other is the lesson we have. Now adapting those two into the different system, like an energy system, as I mentioned. Then the changing from waterfall supply chain to bidirectional value network. That's not seriously talking in the Japanese government or Japanese people. Used to be, many existing systems is just a waterfall, one directional controlling system. End user just eat the bytes and bits or the things, right? Though when you grab smartphone be able to talk to the network, can talk to the servers. Used to be, supplier like to provide those just one way. Users should follow. That was the past. Okay, so changing from waterfall to bidirectional value network. Then, one way is the trust has a supplier. So the end user going to be the supplier. Then how to make a trust is not the easy way to do. Okay? So this is my 3 simple proposal to the energy system. Globally connected infrastructure is a given thing. Again, when we talk about energy system, likely we discuss national infrastructure. Though when you observe the data center networks, it is now global. In short, when the data center went to the power source with the communication fibers, it goes to a very effective, energy efficient infrastructure. So Japan doesn't have energy. So we want to get a power in the North America, Indonesia, or the other area. You provide us very cheap energy. Then we want to put a data center there. Data center got a data or send the data through the glass cable. That is 100 times cheaper than electric cable that I will show. So that is seriously now we are talking about. That is the fiber optical network is quite interesting. The other thing, last part is the EV. because of the gold hair present in North America, people may think the EV is going to be disappear, though that will not happen. Most of you already know about the good thing of the EV. EV has huge computational power in it. Every 5 years, automobile gonna be purchased. And also EV has huge battery capacity that is run by individual, run by user, not run by electric company. That's a huge change of the infrastructure view. End users has huge capability to control the energy system and also the computational thing. In order to do that, we need RegTech. That is a new buzzword we define in Japan. Regulation consideration by technology. Most of the regulation or law used to be based on the analog procedure, right? Signature must be written in the paper. That's stupid, right? You don't care the paper now. The signature is just a bitmap, digital data. So regulation based on the legacy materials. And there are many very ineffective regulation we have. It must be changed by the technological innovation. That's called the regulation changed by digital tech. That is the RegTech. So you may be able to discuss this. What's going to happen when we have the Web3? What kind of stupid regulation we have based on the past industrial structures or activities? That is good chance to discuss about this. Then you can change. Once you can realize this can change the regulation, you can make new business, right? So that we are now, I'm leading the RegTech in digital agency in Japan. That's very hard work. Though I think this should be distributed way. If everyone find out those changing points, then you can propose to the government, or propose to the companies, or propose to the professors. They may have a chance to talk with the government, regulators. That's a multi-stakeholder discussion, I believe. Okay? So this is since the time is up, so this is the key message about the energy. Important thing is, once you have AI, you can reduce more than 30% of energy easily. That I proved in about 10 years ago. When you have the data, you can make more than 30% energy efficient improvement by data. Once you have a controllability, more than 50% you can do. That is called as the EP100. Energy productivity 100 improvement, which means required energy going to be half from the existing system. Then amount of the renewable energy is going to be half. Right? That's the easy way. This is the I calculate in Japan or India and France about the 20% renewable energy. When you have innovation by digital technology to every single country, every single companies, 50% reduce. That's going to be easy to making a carbon neutral. That is a contribution by AI. Though, what's happened right now is AI eating huge energy. So we must take care of them, right? For example, Microsoft is going to buy going to take over the nuclear plant in North America. Micronuke is going to be run by the other companies. So that is the other thing. AI itself contributes to the reduction of energy, though ourselves consume huge energy. Now, how can reduce those AI power? DeepSeek, that is a very simple way. When you have the good coding technology or coding technique, you can reduce the required power quite easily. I really don't like Python. When you write the code by Python, very poor memory management, data transmission, right? But when you have the C code, it's going to be very improved. That's exactly what the DeepSeek did. Right? The technology can be changed, that's the thing, quite easily. So that you should do. Right? So this is the of digital or by digital, so that's since the time is up, so I want to skip this operational carbon thing and the embodied carbon thing. One other thing, embodied carbon thing, that is now, the world is changing. Used to be, people are thinking about the operational carbon, daily energy use. Though from the viewpoint of your age, in order to have a computer, huge iron, huge plastic, the other material we must produce, huge power is consumed by them. So we must think about not only the operational carbon, but also the embodied carbon. I'm sorry. That is the other thing. When you think about the embodied system, that is huge supply chain, right? From the oil, coal, or steel companies, distribution company, or integrated company, that's a huge supply chain network. We must think about this. Then we really need a trust in order to evaluate embodied carbon footprint. That is, seriously, we talk with the car industry now. Car industry have huge operational carbon by every day. So in order to produce the car, we need huge energy. We must grasp the view of the supply chain by digital among the huge number of companies, from the big company like a Ford or Tesla to the tier 1 company or small companies. Every single company on the supply chain network must provide trustable data in order to grasp those snapshots by you in order to help the earth, right? So that is another work you have from the operational carbon. Of course, that is also the multiple stakeholder. That is for a larger thing you must have. And also digital. So I did, as I mentioned, using AI, more than 30% energy cut got easy to do. Then the other thing is going to be a 2B infrastructure. That is I said, RegTech. Changing from AI, changing from as is, using AI. Going to be changing to the new infrastructure with AI, right? So AI is the premises. Though you want to think about new infrastructure, totally different from the existing system. That is changing from as-is system to 2B. When you think about 2B, no regulation at all, because of the new, right? That is the Elon Musk lab, Google lab. Their work style is they want to do the business for the new domain, 2B. Then they can define the regulation by them with the government. That's what Elon Musk are doing now. Okay? So that is important, 2B. how using the AI to the 2B. That's a challenge you can do. Then what is the impact of the photon quantum from the energy point of view is yet another thing. So but first, that is the existing material infrastructure was a long time ago. Then we, human beings, invented container. We have the digital package to the internet. Essentially, container system is the same as the internet. Exactly the same architecture, exactly the same sharing economy. What the internet did is changing from physical object to digital object. That is a huge impact into the resource we must use over the globe, on the globe. Okay, this is the simple rule I want to share with you. In order to move material, physical object versus electricity, versus bit and bytes, 2 order of magnitude different. The bit and bytes are far cheaper than electricity, 100 times, 2 order of magnitude, right? Which means, how collaborate with the power company is this? Power company is very ineffective infrastructure operation. When we change the configuration of the power system using digital bit, those systems going to be 100 times cheaper than existing system. Changing what to the bytes and bits, that we are talking about. Why it's going to come? Technologically, that is a mass of the photon, neutron, electron, and photon. That different from the order. When we think about speed of the mobility, that is 30 million difference, which means when you move those objects, that's too slow, right? 30 kilometers or 10 kilometers per hour. You know, how about the bits? Which is with the 1 second, it goes to the 7.5 Earth circulation. So that is a huge changing you can do by the fully digitized infrastructure. Then we can help them. That's what I proposing to them. That is another thing doing in the China. Generating the power in the eastern part in China. Western part, sorry. Eastern part making huge data. It's a money. So the influence run in the big data going to be sent to the training part in western part in China. After the calculation, influence going to run in the eastern part in China. There's no energy transmission among east and west. Only the bit and byte transmission. There are a huge generator in the western part in China. Then the data center sits nearby the power generator. That's it. Then very energy efficient infrastructure you can make. As I mentioned, you can think about this not only in Chinese domestic solution. Already, Chinese companies are now thinking about the global solution. Where is the energy? Where is the generator? You can put the data center nearby the power generator site, right? That example is the BMW. They check every single process in their company. Then only 20% of data must sit in German. I don't like the national boundary, though they requires by the as a governance required by the government, for example. Some critical data must in German. So though that's only 20%, rest of the 80% can be sit in the other countries. So 80% went to the fully renewable energy site in Sweden and Iceland. Energy cost going to be almost 1/10. Germany is a very expensive power country. So they changed data center to the very cheap energy site, then huge carbon footprint reduction they did with very cheap, operation. That's the money also. So the money reduction, cash out reduction plus helping the earth. Of course, they never say about their saving the cost. They always say this is good for the earth, right? That's their business. That basically came from their very simple law, right? You can think about this as a global way. So this is the example what we're discussing about data center could change the location to where there's a power. So that is one example. The other thing is we have very good space infrastructure as well. That's very cheap compared to the physical fiber system. Of course, the fiber has a huge capacity, though they need the money. Thank you so much for the space industry. The cost of the satellite is going to be dramatically reduced. So that is yet another, alternative you can think about as a global system, right? Then you also think about moon. I believe some of you go to the moon, right? We cannot, though you go to the moon. You can think about moon, the space. Is there any national boundary there? No. So you have the responsibility. How manage the moon? That is different from the existing on the earth countries. Only one second to the moon, right? You should think about this. Also the very small satellite as well. That is new area. You can work, you can make a business, right? So this is the Earth, seen from the space. How about the backside, in the night? This is Europe, North America, India, Japan, Korea. Unfortunately, this is real night in North Korea and South Korea and China. There is national boundary. That's a very stupid thing, right? You can see the border at some location. Though most of the part on the earth, there's no national boundary in the actual system. That is, we must have. That is trusted web or Web3 must have. No national boundary, very simple infrastructure with a trusted thing. That's the goal. So that is the case I want to share with you. This is just the infrastructure history, so I should wrap up this. The last thing I want to share with you is the EV, as I mentioned. EV has a huge battery. That's for the emergency case as well as demand response capability. Never end user has those kind of demand response capability in the past. As I mentioned, in order to move the material, huge energy you require, right? So in order to run the car, very heavy car, you must move with your body, huge energy. They must create it, consume. In order to hand off, you must have very large computational capacities. So how much is this? And also interesting is the car work only 4 to 5%, which means 95% of the time, the car is in parking lot, right? 95% of the time, the car is at parking lot, connected to the network, connected to the power grid. 95% with no work. You are paying only 4 or 5 times usage. That's the car. That's economics. So how about the battery capacity? Once you have 1 million EV, which same to the 30 gigawatt, that is supposed to the emergency backup storage capacity of the largest Japanese power company. Only 1 million. How many cars Toyota Corporation sell in a year? 1 million. BYD, the other companies, right? Less than 1 million. So that is a possible number, which means every year, huge capacity network we are going to get. That is battery. Again, 95% of the time, they never do any work, just sitting in the parking lot. How about, and also the car has mobility, which means battery capacity be able to change the location. That is never existing power company grid has. Mobility plus huge capacity, and also the end user pay off those infrastructure. How about the computation thing? Japan has a number 3 supercomputer called Fukuoka. Every single EV car has a GPU and huge CPU. Once we have the 100K Tesla car, which equal to number 3 supercomputer in the world. Right? Only 100K. Once again, 95% of the time, EV don't work. Means idle GPU, idle CPU we have. Why we must pay to the NVIDIA? Right? In order to have automobile navigation system, every single end user pay money to get a GPU. It's never worked 95% of the time, which is huge infrastructure change going to be able to do. Though, when we think about this infrastructure, every single user have an EV must have the responsibility to control the energy grid. Used to be, since the end user doesn't have such a capacity or capabilities, power grid company can control by themselves independently. So now, the end user participate in to those supply chain network. Then how to trust the end user behavior? How to protect them from the cyber attack? Right? Otherwise, once your EV is going to be hacked, that's going to be easy to attack power grid. Once the power grid collaborates with those infrastructure. So that is, again, going to how think about infrastructure, changing the world. You have a lot of new area. I believe you can work fine. Thank you. That's all.
Thank you so much for your inspiring keynote speech. So that keynote speech is covering fostering trust and using AI, blockchain, and Web3, our camp theme. So yes, thank you again for your speech. And so we have a lot of questions, I guess, because we are from a different organization, and then some of you guys are from the company and the university. All of us have a challenging tasks because we are currently it's an AI era and the digital era. So we also we have a benefit of AI, but energy consumption is huge, and we also have a challenging task on energy reduction. Energy productivity should be improved. So that would be the kind of innovation needs. So it's our task, future tasks. So I would like to have your questions from the audience. Is there any questions?
Yeah, please come here and give your question.
Thank you.
Thank you so much, sir, for an amazing presentation there. So basically, my question is that with the involvement of AI systems, we can definitely achieve energy efficient algorithms or systems or product services. But how do we deal with, like, how can we trust the trustworthiness of the outcomes provided by the AI systems? Basically, can we achieve a common path where we can use the AI systems and we can trust the output provided by it, keeping in mind the factors like biases or underfitting, overfitting, etc.? So that's my question.
Yeah, thank you. That is your challenge, I believe. Because of a lot of players, component are there. Used to be, as I mentioned, very simple infrastructure we can assume. The infrastructure is going to be very complicated, bidirectional system. And also, we may have the AI. You don't know the algorithm itself, right? So now, we must think about what is the trustworthiness of AI. My answer is data. How to provide the secure, trusted data to the AI is the key, the correctness of the AI operation. So that, again, how make trusted or trustworthy of the data in order to correct operation by AI or the other, right? So that's the only AI is very simple you can think about. The similar thing going to apply to not only AI, but data spaces. Because data is going to collaborate to each other now. How you trust the neighbor data? You can trust or not. The existing based business is based on the trusted party are working together. Therefore, we think we may not need any single cybersecurity methodology. Though now, that's changing.
Thank you so much.
Thank you so much. Thank you so much. So is there any questions? Okay, yes.
Hello, thank you so much for your question. Am I audible? Yeah. So my question was regarding the carbon neutral point. You showed us the world maps of these different areas, right? The issue, however, with new and emerging technology is that it uses a lot of the natural resources. So what model do you suggest going forward and keeping the SDGs in mind that these big companies and even us as individuals should adopt for a more secure future?
Yeah, that is one of the things I want to share with you. When we have digital 2B infrastructure, huge natural resource reduction we can do. Not only operational carbon, but embodied carbon, as I mentioned. So we now start to think about all of the inclusive, natural resource consumption by the human being activities. Again, material versus digital bit. 4 order of magnitude. Successfully, you can use digital native infrastructure, then we can reduce material-based transaction. Huge. So that goes to the change of the business model. What I'm showing, the best example is a newspaper. Do you know a newspaper? I don't think so. You never read newspaper, right? Nowadays. When you ask your mom or pap, long time ago, newspaper was delivered by the newspaper company by hands, by car, in the paper. And also they have their own printed factory only for them. That's huge natural resource consumption. Now what you're doing, just seeing the screen, that's it, right? That's a huge natural resource reduction we did in the newspaper, for example. Similar thing you can think about. You can think about a lot. Interesting is that's the reason why I provide you the BMW thing. BMW do not intention to reduce this natural resource, not SDG. What they want to do is get money, right? Because of the huge cost is required for the natural physical resources, they realize that is big opportunity to reduce the cost, the operation, as a gift, SDG gonna come. That's a win-win thing, right? Those important incentive is money.
Can I have a follow-up? So as most of us represent developing nations in the Asia Pacific, is there a certain model of a country that's managing technological alignment as well as SDGs really effectively? And can we look up to them based on your research?
I'm sorry?
Is there a country or a model that's doing amazingly well in terms of aligning technology with SDGs based on your research?
Yeah, that is the big challenge now we want to do. And then I always think about global pictures because especially natural resource is not uniquely distributed over the globe, right? And the cost itself depends on each region or each countries. So that's a good opportunity or good incentive to collaborate to each other. Then, why we have to fight? Right? In order to survive over the globe, we must collaborate to each other. Not the time to fight.
Thank you.
Thank you so much. Okay, I think Martin is the first and the next. 2, 3. Okay.
Thank you for your presentation. Very interesting. Well, you mentioned some initiatives and projects for increasing the efficiency usage of energy, right? So I understand, well, as far as my understanding goes, Kyushu is one of the examples of using data and probably AI to improve the energy usage of the whole city. Mm-hmm. So at this point, I believe they produce more energy than what they consume. So is there any other example or practical case of a city that uses this kind of system? I know you mentioned something about China and Germany, but is there anything more local maybe? Or a specific case of a certain thing that can actually use this kind of systems?
Okay, this is more than 14 years ago.
Mm-hmm.
That I did. I hacked my building, my campus, using TCP/IP. Then we got a data from every single professor's room. We showed to everyone. Mm-hmm. That's it. Then the professor, control the energy. Then 22% in average, more than 40% in peak cut. We did. How much cost we pay? That's very cheap. I asked to the student, assistant professors, no pay. So that is real number you can do.
Thank you very much.
Thank you very much. So next, here, Solomon.
Thank you, Professor. In your presentation, you made a statement that trustworthy is the goal for technology. And you also said AI can reduce energy consumption approximately 30%. And if my memory serves me right, I don't see any global regulation for AI. Europe has their own way of regulating. America has allowed the industry to regulate itself. And I don't think if Japan has regulation for AI. And since we want to create a society where there is connection and easy to share information at a lower cost, how do we trust AI since there's no, regulatory backing? Because right now, if we go to the carbon neutrality, we know there are so many regulations about it, and now all the organizations are going ESG path. So how do we, coordinate the regulatory aspects so that we can, have this kind of trustworthy in sharing information? Thank you.
Thank you. That is the reason why I put what is the internet first. Distributed, cooperative system, autonomous operation. When the government making a law, regulation, that's not a multi-stakeholder discussion, nor autonomous operation. Of course, it's the autonomous operation. There's a bad guy and good guy coexist. That is real fight. How to educate bad guy, how to reduce the bad guy. Then you may know about the active cyber security, cyber defense. Japanese people misunderstood, Japanese politicians misunderstood about active cyber defense. Though in the global way, active cyber defense is attacker give up the attack when the defender has a good capability, right? Because attacking cannot make money if the defender has a good, defensive capability. That's active cybersecurity. Active means proactive, right? So proactively, how the attacker do? You can evaluate, you can consider, then you can prepare for those proactive attacking. Then they, give up to attack. That is active cybersecurity consideration. So similar thing I think we should do. Regarding AI, of course, the bad usage, they do. Though how to protect those bad data insert. Every single AI provider checking those things by themselves. That's going to be healthiest way. How about what's going to happen when the government making the rule or enforcement do that? That lose autonomous idea thing. So that is why Japan doesn't have any such a strict rule for the AI, data management. Of course, the EU has a different. United States has a different. United States more freedom, though that came from the national security point of view, right? So that is multi-stakeholder discussion. A lot of variety of the things going to be okay. That's the reason why I mentioned multiple trust anchors. If the government enforce single trust anchor, there's no way to escape from the attack. We need an alternative. That is, I didn't touch on the premises of the internet. Internet always provide alternative. Alternative is always important to making the resiliency of the innovation as well as operation. Okay?
Thank you so much for your amazing presentation, Professor. What I really like is the highlight of how using EV as the automobile source, like how 95% of the time we're not using the vehicle, and there's a massive amount of renewable energy stored there, which we can use to actually potentially implement the new domain. However, what I think here, currently there's a very strong, serious cutthroat competition going on in the EV market from, for example, BYD, even from the Japanese segment and foreign countries. But if you see, there's a massive potential lying here, since most of the countries, even if we see I'm from Bangladesh, the developing countries haven't implemented EV solutions yet. But there should be a collaboration between the companies, but also the government to have trust anchors and develop a total, truly renewable system like that. How much do you think is that implementable, achieving that level of connection?
Thank you. That is a quite important and interesting question. Many historical technology came from the developed country to the emerging countries. It was history. Though when you carefully look at the business case or use case, when you have very good, effective solution in your country, it can be applied to the advanced country. Reverse way, that's a reverse innovation call. One of the example is the medical system in India. India doesn't have a huge hospital, doctor's office. The structure itself similar to the United States. The United States, based on the hospital, has a huge money and huge investment. Means very big medical equipment going to sit in the hospital, not in the doctor's office. Though in case of India, that's a huge cost. So they decided to making very mobile, cheap medical devices for per doctor's office. Then, rest of the country going to stealing those ideas. That's reverse engineering. So, of course, you have a different hard situation. That is a good opportunity to have innovation.
Thank you so much, Professor.
Thank you so much. So due to the time limitation, so he is the last, question.
Hi, my name is Kenny. So I realized that you proposed a simple proposal with 0, 1, 2, 3, the steps. I think they all perfectly make sense, but only in the step 0, you talk about globally connected infrastructure, right? For me, when I interpret that word, it means that there will be no geopolitical issue between countries. That's why you can be globally connected, right? And you use the example about how India, US, and Japan can cooperate with each other to make reduce the energy consumption, right? But actually, if you can also cooperate, let's say with China, could be, that will be make even better result. But you cannot do that because if you put China on the chart, right, there will be a third world, let's say trade war or other things, right? So in that sense, right, how can you really build trust? Because you talk about setting up data centers between different countries, right? But right now, maybe, you can see that we have President Trump or other crazy presidents, right? There's no way we can really solve the geopolitical issue. When you have no step 0, that means all other steps cannot be implemented because if you can really cooperate with each other, of course, all the issue will be solved. But so in your opinion, right, I'm asking maybe more about your perspective from a practical side do you think that the government can really cooperate with one another to build trust so that we can enforce that trust using the AI? Because otherwise, if there's no trust between government, right, what is the point of the step 1 and step 2 and step 3?
Yeah, thank you. That is the hardest question. Though, that is how to change the thing. It's basically, I believe, economy. And also the people, you can change the nationality. When I talk to the Chinese people recently, they want to go out from China because of the very strong regulation by the government. Dictator, I cannot say the name though. That is happening in the real human being activities. That change the nation because basically the nation based on the economical activities. So how to change the economic activity is a key to change the nation. And also, you are now globally living. Do you care about the nationality? I think you do care about nationality. So you can change. You can go to Japan or go to the United States. Of course, some government, try to stop. Though fortunately, Of course, there is a firewall, great firewall in China, though. When I talk with the students in China, they use TOR, onion routing, to connect to the internet. The other thing I share with you is the Ukraine asking us disconnecting Russian internet when they invaded about 5 years ago. Our decision was do not disconnect the Russia because Russia's citizens lose the opportunity to get a correct data from outside Russia. Ukraine want to stop the economy of the Russia by disconnecting the Russian network from the internet. So what we think about is always think about end user. End user must be able to get information from the rest of the world. Then how to think about Russian citizens is up to them. So we want to provide them opportunity, alternatives. Think about. That's what we did about the very urgent case, what our decision making. Similar decision making we did was the 9/11 attack to the Twin Tower in the Manhattan in New York. At that time, United States government want to stop the internet. Wanted. Very high level discussion they did. So their decision came from economy. What's going to happen when they stop the internet in the US economy? That's going to be disrupt. That is the reason why they stop stopping the internet against such a quite serious, incident, attack. It went to the war. Though fortunately we do not stop the internet because of economy.
Okay, thank you.
Thank you so much. So thank you so much once again. So Professor Esaki. So I think.
Thank you.
Thank you so much.
Thank you very much.
So much. So Professor Esaki will be staying until March 15th. So if you have any other comments, please find him and then ask other questions to him. Okay, thank you. And then the fellows are also doing the collaboration, the group work project. So he brought a lot of thoughtful perspectives. So in terms of the DX and GX and the new energy areas. So there's a lot of business idea and the innovation is required in this field. So you can also reflect his presentation to your group work activity. So thank you so much. And then we are going